In order to start an animation using code, you can just call the begin method of the storyboard object that you define in your markup. On the other hand, you have to move the storyboard somewhere where you can find it in code. We had it buried inside a trigger before, but that isn't going to work. Generally, you store it as a resource in the host container that contains whatever markup you're using. In our case, we'll store it as a resource in a user control. We'll find it from within the code and then call its begin method to get it going. Let's look at how we can call the begin method of a storyboard object from code to start the animation running. In this example, when I click the button, we'll run code that will begin a storyboard that does nothing more than change the width of the button over a period of time. A simple animation. Remember what that looks like. Let's go look at the markup and the code that makes that happen. Here in our example, we have a button whose name is Demo Button, whose current width is 75. We also have within usercontrol.resources a storyboard whose key value is Demo Storyboard. Inside that we have a double animation whose target name property is Demo Button, target property is width, changes it from 75 to 300 over a period of 2 seconds. So we've defined a resource which is the storyboard, and we've given it a key so we can refer to it in code. The key is Demo Storyboard. Now, in reaction to clicking the button, all we have to do is find this resource and then call its begin method. In the code, we look at the Demo Button _ click event handler. We have to find the resource first. And the way you find the resource is given its key value, call the try_find_resource method. We need to cast it as the right kind of object, so I'll cast it as a storyboard. I have a variable declared here to hold that value, which will either contain a storyboard named Demo Storyboard or a null reference. If SBD isn't a null reference, then we know we found the storyboard, and we can call its begin method. Calling the begin method is the same as using the begin storyboard element that we saw in previous examples. So the steps are: find the resource, if it's not null, call its begin method. That's all there is. So you could use this same code in reaction to any event of any object to call the begin method of the storyboard and have the storyboard start running whatever animation or animations occur inside of it. Every animation we've seen so far uses the double animation class to animate a double value. The color animation class takes on the same role, except it animates a change in a color. The color varies over time when you use a color animation class. The from and the to values then contain color information as opposed to double values. What if you want to animate the fill property of an object? Well, you can't directly. Here's the problem. The fill property normally is set to a string that contains a color. But you're not really setting the fill property to a string. You're setting the fill property to a solid color brush. What you're really setting is the color property of that solid color brush. So what you have to do then is set the target property of your storyboard to be, say you're modifying the fill property of a rectangle, you'll have to use rectangle.fill.solidColorBrush.color. I know it seems like a lot of typing just to set the fill property, but the problem is fill isn't a color. Fill is a brush, and that takes a little more effort. It isn't a color. It's a shortcut for more complex markup. When you actually set the fill property of a rectangle to be red, what you're really doing is this. You're setting rectangle.fill to be a solid color brush whose color property is red. Given all that, in order to set the target property, you need to indicate that you're setting rectangle.fill.solidBrush.color. Now I've put them both in parentheses to indicate that rectangle.fill is one property, and a property of that property is solidColorBrush.color. So you get this strange syntax. The parentheses group the properties, and you also use the same syntax for attached properties. Basically, any place you want to indicate that a complex expression contains a single property, you put it in parentheses so the parser can understand it. Given all that information, let's look at an example that will animate the color of a brush that provides the fill for a rectangle. In this example, we're going to animate changing the color of this rectangle when the mouse enters and then when the mouse leaves the rectangle. When we enter the rectangle, the color animates changing from red to yellow. When I leave the rectangle, it animates changing back to red. Let's try it again. Red to yellow, yellow to red. How is that happening? Well, let's go look at our markup for this example. You'll find within the grid a rectangle here, defined right now with a fill of red, and name is rect. Inside that rectangle, we have rectangle.triggers. We have an event trigger reacting to the mouse enter event. We have our event trigger.actions. And within there, we have the begin storyboard action, defining a storyboard where we have a color animation animating from red to yellow over a period of 1 second. The target name is rect, and the target property is rectangle.fill.solidcolorbrush.color. So we're going to find the fill property of the rectangle, and for that fill property, make a solidcolorbrush.color, and we're animating that property. We have another trigger for the routed event, which is rectangle.mouseleave. Again, we have event trigger.actions, begin storyboard. We have the storyboard we want to run. We have a color animation which goes from yellow to red. Duration is 1 second. The target name is rect. And the property we're working with is the same property, rectangle.fill.solidcolorbrush.color. Now, in this example, I use triggers, and you see how much typing is involved in using a trigger. Now, it is declarative. There's no program code here. You could easily have written the same thing using just a tiny bit of code to retrieve a reference to the storyboard and then call its begin method if you had stored the storyboard as a resource on this user control. It would have been less typing, but it would have required adding program code as opposed to markup, as in this example. It's really up to you which way you want to create your event handlers, as triggers or as event procedures. Either way, you get the same behavior. Let me run it one more time, and you'll see as we enter the rectangle, the color changes to yellow. As we leave the rectangle, the color changes back to red. The point animation class animates a point, just like the color animation class animates a color, and the double animation class animates a double value. The sample will animate the center of a path object. Here's the sample we'll be looking at. That is, we'll take an ellipse geometry whose center is 100, 100, and animate that point value. This is why the ellipse geometry is easier for animating than it is to animate an ellipse shape, because the ellipse geometry has a center property, which is a point. If you animate an ellipse shape, you have to animate both the canvas.top and canvas.left to move it. But with an ellipse geometry, you can just animate the single value, which is the center point. Let's look at an example that does that. In this example, we're animating the center point of that circle, going back and forth and back and forth. And notice that this animation repeats back and forth forever. It won't stop until I close this user control. So there must be something special going on to make that happen in addition to animating the point. It's not related to animating the point. We could be doing any animation in this way, repeating back and forth forever. But let's look at the markup to see how we're executing this particular animation. You can see here that we have a path describing an ellipse geometry. We have a name for it, which is circle. the center, which is 100, 100, and the radius x and radius y values, and it's filled with green, as you saw. But our animation is going to include a point animation. The target property is center. See, there's the center property. That's what we're animating. The target name is circle. That's our ellipse geometry named circle. The duration is 3 seconds, and we animate it from 100, 100 to 300, 300. That would just do the animation once. But we can also set the auto reverse attribute to be true. The default, of course, is false. By setting the auto reverse attribute to be true, this animation runs forward and then goes back to where it started. We can also set the repeat behavior to forever, and that causes this repeating forever, and we'll just keep running until we shut this thing down. We'll come back and look more at those variables later on, but it does show that you can cause an animation to run continuously, going back and forth and back and forth. That's what caused the ball to go from its current location to 300, 300 and back to its original location. If we run the animation again, you'll see that it does that. It goes from 100, 100 to 300, 300 and back the other direction, and it repeats this animation over and over until I close this user control. Every animation we've seen so far uses linear interpolation. That is, you're changing a property from the from value to the to value linearly over time. You can also use keyframes. You can use a class like double animation using keyframes. This indicates specific values for a property at specific times. Between specific times, the rendering engine uses various methods, which you indicate, of changing the property from one value to another. The animation's target values are defined by the keyframes element, which contains a collection of double keyframe, or other types as well. You supply the value and key time properties. You could say, imagine you're changing the width of a button. You could say at 2 seconds, I want the value to be 100. At 4 seconds, I want the value to be 200. And I will tell you whether to do that linearly, whether to do it immediately, whether to use some other curve to represent the change over time. So you get all those options you can set when telling the animation how to use the keyframe. Now, how do you move from one keyframe to another? That involves interpolation methods. You can select from a number of interpolation methods. There's linear double keyframe. That's a smooth interpolated change for the value to the key time. That would be like every animation we've seen so far. We could say the button's width at 1 second is 100. The button's width at 2 seconds should be 200, and interpolate smoothly over that time. That would be if you asked for the linear double keyframe. The keyframe animates the target value of the previous keyframe to its own target value, interpolating smoothly. There's also discrete double keyframe. This one causes the value to jump without interpolation. So if you used a discrete double keyframe, and the previous keyframe had the width of the button at 100, and the current keyframe has the width of the button at 200, if you're using the discrete double keyframe for interpolation, it would just magically jump from 100 to 200 at 2 seconds. You're jumping from the previous target value to this keyframe's target value at the specific time. Another interpolation method is the spline double keyframe. This creates a variable transition between values defined by a keyspline property. This uses splined interpolation based on a spline curve. You've seen curves before. Imagine that you want to change a value from 100 to 200 using a curve. Well, the curve might indicate that for the first 1/4 second, the width changes very slowly. Then as the time increases, the speed of the change also increases. This provides a more real-world interpolation effects like acceleration and deceleration as the value changes. The spline consists of 2 endpoints, assumed to be 0 and 1, and you add 2 control points anywhere on the curve. The control points determine the shape and the behavior, and it's easier to see this visually. We'll do that later in expression blend. But what this sounds like to me is a Bezier curve, and that's exactly what it is. The spline curve is a Bezier curve that defines the acceleration or deceleration of the change in the value. And this allows you to have changes in values look far more realistic, giving it a physics look. You've played computer games. They all use this same sort of interpolation between key frames. So when you drop a ball, for example, it doesn't just go chunk on the ground. It accelerates as if it were under the effect of gravity. Let's try an example using keyframes to animate the movement of an object. If you watch this keyframe animation carefully, you'll see that it has specific locations at specific times. Watch now. You'll see that both the horizontal and the vertical movement changed. Now we pause here until a certain time it pops back to the top and starts over again. So this animation is using linear interpolation, keyframe interpolation, and discrete jumps from one place to another. We'll need to stop and look at that markup carefully to see how this shape is being animated. Let me shut this down for now and look at the markup. We have here a rectangle. Not very interesting. Its name is rect. That's not the key. The point is we have a storyboard that contains 2 double animation using keyframes elements. One of them animates the left property, one of them animates the top property. You can see we have the repeat behavior set to forever, so this animation occurs over and over and over again. Let me start by commenting out one of these animations. It's easier to view what's going on if you're only watching one property being changed at a time. The first animation, the double animation using keyframes element here, modifies the canvas.left property of rect. That's our rectangle. You'll notice that we have 4 keyframes here. At time 0, our left should be 0. At time 2, our value should be 120. At time 4, the value should be 150. And at time 6 seconds, the value should be back at 0. So it's going to move from the left of 0 to the right out to 120 by 2 seconds. By 4 seconds, it'll be at 150, and by 6 seconds, it'll be back at 0 again. But what happens between those keyframes? Well, imagine we've just finished the animation. We're starting over again. We're moving from position 0 to position 0, and we do it at time 0. Well, linear double keyframe doesn't really do anything because we're not moving from this to this, so it didn't really matter what type of keyframe we chose here. We're not going anywhere at time 0. But to get from time 0 to time 2, we need to move from 0 to 120. Do we do that in a linear fashion or based on some curve that changes the speed at which we move over time? Well, this one's linear. We're just going to space out the distance from 0 to 120 and move evenly over that distance over the time. Now, between 120 and 150, over 2 seconds, from 2 to 4, we're using a spline double keyframe. That means the shape of the curve, which defines the speed of the movement, will change over time. We haven't specified what spline we should use, so we're using the built-in default spline curve, and you'll see that behavior. It won't move linearly over time, though. Finally, from 4 to 6 seconds, we need to move from 150 back to 0. Again, we're using a spline double keyframe for which we have not specified the exact shape of the curve, so we'll use the same built-in curve that defines the speed at which we'll move. Now, we're going to move back to our demonstration. Watch what happens. The block will move from 0 to 120 in 2 seconds smoothly. It will then move from 120 to 150 over 2 seconds, but not in a linear fashion. It will move from 150 back to 0 again over the final 2 seconds, again, not in a linear fashion. Let's run this again. Watch the left coordinate of this block. It gets to 120 and then it starts moving slower and slows down as it moves. Watch, it slows down, then back to 0 again. The spline curve that's the default is actually seems pretty linear to me. It does slow down because we have less distance to cover over those 2 seconds. But the spline curve we get isn't very obvious what it is. It may just be a straight line for all I know. In our next portion of this demonstration, we'll look at a spline curve where we do alter the shape of the curve. So in this case, we're just moving from 0 to 120, 120 to 150, and 150 back to 0 at specified intervals, which we've specified here in these linear double keyframe elements or spline double keyframe elements. 0 seconds, 2 seconds, 4 seconds, and 6 seconds. Well, let's look at how we change the vertical component of the movement of that rectangle. Let me uncomment that animation and comment this animation out. There we are. Now, in this example, we are moving canvas.top for our rectangle. At 2 seconds, we need to have a value of 0. At 4 seconds, we need to have a value of 80. At 7 seconds, we need to have a value of 0 again. So it looks like between 7 seconds, the length of our animation is going to be 7 seconds. That's the longer of the two. The animation takes 7 seconds. And between 7 seconds, repeating back to 0, and from there to 2 seconds, we just sit with a vertical position of 0. From that position, we need to move to 80 over a period of 2 seconds. Here we have a spline double keyframe where we've defined the key spline. A key spline consists of the 2 control points at 1, 0 and 1, 0. Now, here, I just made up these numbers. You can make up other numbers. Or you could use some design tool, like Expression Blend, that lets you create a spline curve. It generates the markup for it, so you can see what it looks like in terms of acceleration of this block as it moves. In this case, I just guessed. And when I look at the speed of the thing, you'll see that it's not linear. The speed changes over those 2 seconds. We need to get from 0 to 80 vertically over 2 seconds using whatever curve this key spline generates. Finally, from 4 seconds to 7 seconds, we need to get from 80 back to 0. We don't do it linearly. We don't do it using a spline curve. Instead, we have a discrete double keyframe which just says, at 7 seconds, pop back up to 0. Don't move slowly, don't make it gradual, just pop right back to 0. Let's watch this animation work. And this is just the vertical component of our animation. At 2 seconds, we're sitting there. At 4, we need to be at 80. And at 7, we're back to 0. At 2, we're at 0. Watch how we get from 2 seconds to 4 seconds. You saw it starts moving very slowly and then moves quickly. Watch. Slow, fast. And you can see that occurs because we're using a spline curve to control the vertical movement. Now, you can't actually see the curve. You have to imagine the curve starts slowly and its slope gets steep as we move in time. We'll see an example of visualizing this in our next section. But for now, you can imagine that the speed starts slow and it accelerates over time. Now, that isn't a gravitational curve. Gravitation wouldn't cause it to start really slow and move faster, maybe on Jupiter or something. On Earth, that doesn't match reality. It does show you some change to the rate of speed for this rectangle. To finish off, I'm going to uncomment both animations and let you watch both of them occurring at the same time again. There we go. Let's run it one more time. Now you see horizontal motion. Finally, the vertical motion kicks in. It starts slow, moves fast. Horizontally back to the left, we pop to the top again. Your brain has to keep track of a lot of different animations using this example. But if you look at the markup carefully and watch the block moving, you should be able to correlate both vertical and horizontal movement of this block using the keyframes for animation. Animation properties seem simple, but they're worth discussing. And there are interesting ramifications of some of these properties. For example, the from property in an animation specifies the starting point for the animated property. But what if you don't specify it? I mean, you're moving, say, a button from one location to another. You don't really want to specify the from location because the from location is where it is right now. If you don't specify it, the animation starts at the current value, as it should. What happens if you restart the animation multiple times without specifying the from? Well, the animation still continues from its current value. Note that the duration doesn't change, however. Now imagine what I'm talking about here is, say you click a button to change the width of that button, and then you click it again while it's still changing. The animation still continues from its current value, the current width, but the duration doesn't change. So if you had a button animated to go from, say, a width of 100 to a width of 300, and you didn't specify the beginning location, the beginning size. So originally, you were moving 200 pixels over a period of time. But now if you start in the middle, now maybe you're only moving 50 pixels over that same duration of time. Since the duration doesn't change, the animation appears to be going slower. You just have to be aware of that. Multiple restarts will cause the change to occur slower because there's a shorter distance over which to travel in the same duration. Now, to leave out the from, the property must have its own value, can't be inheriting that value from a parent container. For example, what if you're animating the width of something, but that something gets its width by just not specifying a width and getting it from its parent container? In that case, you won't be able to leave out the from because there is no specified width value for the object. So you can't take it for granted. If you leave out the from, there has to be a value from which to start, a specified value in the markup for that element. Let's look at an example that demonstrates leaving out or working with the from property. In this example, we have a button. Its name is Demo Button. Its current width is 75. We have an animation we're going to run in reaction to clicking the button. I'll begin the storyboard when I click the button. You've seen how to do that. And here, I'm going to modify the width property to 500 over a period of 5 seconds, but I'm not specifying the from. In this case, the from is whatever its current width is. Right now it's 75, so if I just play by the rules and click once, then we'll animate from 75 to 500 over a period of 5 seconds. Let's try it. And look, it works fine. I go from 75 to 500 over a period of 5 seconds. Let me see if I can restart this again. Now watch what happens if I click twice. I click once, and the speed is pretty fast. I click again, and keep clicking, and it gets slower and slower and slower because the duration of that animation continues to be 5 seconds. But the width over which we're changing gets smaller and smaller and smaller. So the frame rate gets lower and lower and lower. It slows down. You want to see that again? Let me try it again. Here we go. Starts out pretty fast. If I click it multiple times, each time I click it, it gets slower because we're only moving from, say, 450 to 500 over a period of 5 seconds. Because each time we restart the storyboard, it doesn't recalculate the from, it uses the current from. And the duration is always going to be 5 seconds. So you need to be aware of that if you don't specify the from property as part of your animation. You can see this example, we don't have a from, we just have a to value. The to property specifies the endpoint for the animation, that is, its destination. You can omit the to, and the animation will use the property's original value, not taking into account the animation. I suggest you don't omit the to In general, you want to set the value of this property or use the by property, which we're about to see. Either to or by should be specified. The by property indicates a change to the property by a specific increment. It's useful to have the property change a specific amount rather than end at a particular value. You can say, I'd like to have the value grow by 500 as opposed to end at 500. You can use either to or by, but you should specify one of them. Let's look at an example that uses the by property instead of the to property. In this simple example, we have a button named Demo Button, and in our animation, which will trigger by clicking the button, we modify Demo Button's width property by 10 pixels. What could be simpler than that? If we come and run it, here, when I click the button, we change the width property by 10. And every time we click it, we change it by 10 more. You can see we haven't specified the from or the to value, only by. And so it changes a relative 10 pixels every time I click it. Now there's a useful modification you might make here, and that is setting the auto reverse property to true. We'll talk about auto reverse in more detail in just a moment, but if I run this again now, you'll see that when I click the button, it increases by 10 and then automatically decreases by 10 again. So combining the by property with the auto reverse property, you can get animations to run forwards and backwards by a certain amount. In this example, we haven't specified from or to, just by, indicating we'll be changing the value by a relative 10 pixels. The duration property is really simple. All you do is supply a duration object, which is much like a time span object that represents the length of time. In markup, you can supply a string in this format, HH:MM:SS dot fraction of a second. But how is duration different than time span? Why didn't we just use a time span object in the markup? Duration includes a special value, duration.automatic. In markup, you specify the string automatic for the duration property, or just don't specify a value at all. That's the default value, and you'll get 1 second. Your animation will take 1 second if you use automatic or specify nothing at all. There's also the duration.forever value, which is just the string forever in the markup. And in that case, your duration will last, well, forever. Your animation runs forever. And this really only makes sense if you also set the auto reverse property to true. If you set the duration to forever and auto reverse to true, your animation just runs forever, back and forth and back and forth and back and forth, until you run out of patience, time, or electricity. The auto reverse property, when set to true, causes the animation to run and then reverse itself. Of course, the animation then takes twice as long as the duration that's specified. If you had said, I want to run this animation for 5 seconds and auto reverse was set to true, the full animation would take 10 seconds. They don't double the speed to fit in the original duration, they just double the duration of the animation. Let's try a demonstration that shows off using the auto reverse property. In this demonstration, we have a button named Demo Button, and our animation, which again we trigger by clicking on the button, is going to change the width property to 200. We didn't specify the from, it's using the current value, and we've set auto reverse to true. You can probably imagine exactly what this is going to do. If I click it, it will go to 200 and back to 75. 200, back to 75. So it's exactly like the demo we just saw, except this one uses the to property as opposed to the by property. But otherwise, when you set auto reverse to true, the animation runs forward and then back again. We didn't specify in this case a duration, so it takes exactly 1 second. The full animation then takes 2 seconds. Because the auto reverse is true, it runs 1 second to 200 and then 1 second back to 75 again. You can use the repeat behavior property to control how many times an animation repeats. By default, it's set to execute once, but you can alter that behavior. To repeat a set number of times, set the property to a number followed by x, like 3x. In this example, we have a double animation that's animating the left property of a circle, and we're animating it from 10 to 300, and we want this to happen 3 times. The repeat behavior is set to 3x. It will just run 3 times. Now, since we didn't set the auto reverse to true, this will just go from 10 to 300, from 10 to 300, from 10 to 300, and won't go back gracefully. You want to mix the auto reverse property in there to make it look a little smoother. If auto reverse is set to true, the entire animation completes, both forwards and backwards, the number of times you've specified. For example, you might see markup like this, where auto reverse is true, repeat behavior is 3x, and this will go from 10 to 300 and then 300 back to 10. Each half of that will take 2 seconds. We'll have a 4-second complete animation, which will run 3 times, so the entire animation will take 12 seconds. You can repeat for a particular length of time rather than a set number of times. To do that, you set the repeat behavior property to a duration. If not an exact duplicate of the animation duration, it repeats a fractional number of times. That is, it might repeat 2 3/4 times. Imagine this markup, which has auto reverse set to true, repeat behavior equal duration of 7 seconds, and a duration of 2 seconds. So what will this do? This will go forward for 2 seconds and back for 2 seconds. That's 4 seconds. It'll go forward for 2 seconds and then go back for 1 second, because that's all that's left, and will stop. This animation will repeat forward and halfway back, and then just stop. We'll see an example of this in action. You can also set the repeat behavior property to forever. In that case, the animation repeats endlessly. Imagine this markup. This has auto reverse set to true, repeat behavior set to forever, and duration set to 2 seconds. So we'll go from 10 to 300 back to 10, from 10 to 300 back to 10, 10 to 300 back to 10, each repetition taking 4 seconds, and it repeats forever. We've seen examples of behavior like this already. Let's try some examples that demonstrate different ways of using the repeat behavior property. In our first example, we have a circle we're moving from 10 to 300, changing the canvas.left property with a repeat behavior of 3x. So if I run that, we'll see we moved from left to right, from left to right, from left to right 3 times, and we stop. In the next example, we do the same thing, except we set auto reverse to true, and that's the only change. If we run that one, we'll go forwards and back, forwards and back, and one last time we go forwards and back, and each half of that takes 2 seconds, so we just spent 12 seconds of our life watching a ball go backwards and forwards. You can't get those 12 seconds back. Next, we'll look at the same example, but this time set the repeat behavior to 7 seconds, so we'll only waste 7 seconds of our life this time. And in this case, because the duration is 2 seconds, we go forward for 2, back for 2, forward for 2, and back for 1. We're out of time. Let's try this one. Forward for 2, back for 2, forward for 2, back for 1, and we stop halfway because we ran out of time before we could complete that animation. In our fourth example, we repeat forever. The repeat behavior is set to the value forever, auto reverse is true, duration is 2 seconds. We could spend many happy hours watching the bouncing red ball go backwards and forwards and backwards and forwards and backwards. No, never mind. So we'll stop it here. But you could watch this go on forever. Obviously, this will repeat until the application ends, we shut down the computer, or some catastrophe occurs. What if you need more than one simultaneous animation, but you want to delay one or more of those animations? You can set the begin time to delay specific animations. I just also want to mention at this point that you have the option of factoring out the target name property and applying it to the storyboard. You can place the target property setting in the animation and the target name property on the parent storyboard element. Beware if you do this, however, because if you do and later on add animations that apply to a different element, you may be surprised if you don't place the target name property in those animations as well. So I only factor out the target name when I'm sure I'm going to only have animations on a particular single object. Let's look at an example that uses the begin time property to have different animations start at different times. In this example, we're animating properties of an element named circle. It's our ellipse. And you can see we have 3 animations we're applying to various properties of that ellipse, and I've factored the target name property out and placed it here on the storyboard. First, we're modifying canvas.left from 10 to 300. Auto reverse is true. We do it 3 times over 2 seconds. So we're going left to right and right to left and left to right, right to left, back and forth, and so on 3 times. We also have an animation that modifies the height property. We're going to increase it by 100 and auto reverse. So it'll increase by 100, go back to its original value. The duration for this is 2 seconds, but we don't begin until 4 seconds have gone by. We also have an animation on the width property of the ellipse. We increase it by 100. Auto reverse is true. The duration is 2 seconds, but the begin time for this animation isn't until we hit 6 seconds. So we're running this 3 times. Let's think about this. Each animation takes 4 seconds because we go forward and back on the first animation, forward and back on the second. So at 4 seconds, we're just finishing the first animation. We start the second one. At 6 seconds, we're halfway through the second animation. That means we're going forward and back and forward again. At this point, we start the animation on the width property. Well, let's watch this one in action. Here it goes. Go forward and back. We're at 2 seconds. 4 seconds, we begin the next animation. And at 6 seconds, we begin the final animation, which is changing the width property forward and back. And it took 2 seconds. There was a combination of several different animations there. Let's try it again. At 2 seconds, we start back. At 4 seconds, we start the height animation. At 6 seconds, we start the width animation. At 8 seconds, we finish the width animation, and we finish the whole thing there. And so we ran our 3 animations, each starting at a different time. You can use the begin time property to make that effect happen.